Good evening, students. Today I will start my discussion on the electronic factors which influence organic reactions, mainly inductive effect, electromagnetic effect, resonance effect, and hyperconjugation. These electronic factors involve organic molecules, most of which are made from the combinations of the following elements, 6 elements like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And yet the limited number of building blocks does not prevent the organic compounds from taking part on diverse properties in their physical characteristics and chemical reactivity. The subtle differentiation of various compounds in organic chemistry is essential for the biological functions of the molecules and create wide variety of reactions. So these are some of the examples like propane C3H8, propanol C3H8O, propionic acid C3H6O2. So the development of polarity in between the two covalently bonded atoms due to the difference in electronegativity is called inductive effect. This effect is also called field effect or space phenomenon. See, if we take the covalent bonded atoms, two covalent bonded atoms in which there will be development of polarity, okay, and which is due to mainly difference in the electronegativity, is called by the name inductive effect. Say for example, if you take a covalent bonded compound between A and B, A is having a small positive charge and B is having a small negative charge. So the negative charged B is more electronegative when compared to A, which is electropositive. So in this case, if you take the example of the carbon and halogen bonded compounds. So here we know halogens are more electronegative and carbon is electropositive. So if you take this here, the carbon is bonded to chlorine. So chlorine is more electronegative. So as a result, what will happen? The chlorine will get a small negative charge and carbon will get a small positive charge. So when you take the example of this and this bond, you know this carbon which is bonded to halogen, it has got a small positive charge and it is electron deficient. So it attracts the electron from this next neighboring carbon atom, and as a result this carbon gets a small slight positive charge, and this carbon again it draws the electron from this carbon atom and get a small positive charge. So like this, this effect, which is mainly due to the difference in the this development of polarity is mainly due to the difference in the electronegativity of the two bonded atoms. So the inductive effect always decreases on the increasing distance. So say for example, in the previous example just we have seen here, as there is a distance between the carbon and halogen, it goes on increasing, the inductive effect also goes on decreasing. So this is how it can be given. So inductive effect is inversely proportional to the distance, so which can be represented by an arrow in the middle of the bond towards the electron withdrawing atom or the group. So just I will show it here. So this is the arrow which is showing or pointing towards the carbon and the more electronegative atom. Similarly, this you can show by the arrow. This is also arrow which is indicating the inductive effect. That is arrow in the middle of the bond towards the electron withdrawing group. So just you can see the arrow is between the two atoms which is pointing towards the more electronegative atoms, electronegative or electron withdrawing group. So depending upon the atom or group of atoms, If it withdraws the electron, then the effect shown by the group can be called as negative inductive effect or minus I effect. If the atom or group of atom withdraws the electron, then the effect shown by such a group is called as inductive effect or minus I effect. And such atoms or groups are more electronegative than the carbon. So also they are called as electron withdrawing species. So the common atoms or groups which cause negative inductive effect is given by this order. So this is a decreasing order of the negative inductive effect or minus I effect. So these are some of the atoms or the groups. You can see the order can be given like this. So if it is between the chlorine and carbon, then chlorine is automatically an electron withdrawing group. So there is a minus I effect. It is minus I effect of chlorine. So you can show these are some of the groups which are showing the decreasing order of minus I effect. So if the atoms or groups releases the electron, then the effect shown by such groups are called as positive inductive effect or plus I effect. And such atoms or groups are more electropositive than the carbon, and they are also called as electron releasing species. So some of the common atoms or groups which can cause plus I effect are, these are some of the groups or atoms which can show plus I effect, and this is a decreasing order of the plus I effect of all these atoms or groups. So if you take here, there is a plus I effect of the CH3 group which is showing towards the carbon. So electron releasing groups usually they cause plus I effect. So there are some applications of inductive effect which is mainly given in the comparison of acidic strength of organic acids. So acidic strength is directly proportional to minus I effect, and it is inversely proportional to plus I effect. So these are some of the organic acids which are given in the comparison of their acidic strength. So among this, the formic acid is the strongest acid and butanic acid is the weakest acid. And if these aliphatic organic acids, if one of the hydrogen is substituted by halogen, then their acidic strength can be readily increased because of the minus I effect of the chlorine element, which is an electron withdrawing group. So if you take trichloroacetic acid is more stronger acid than dichloro, which in turn is more than chloroacetic acid. So this chloroacetic acid is more stronger than formic acid, and this formic acid is more stronger than acetic acid. So acetic acid is the weakest acid when compared to formic acid. So like this minus I effect can be given to explain the acidic strength of the organic acids. So now let us go for the next electronic factor, which is called as electromeric effect. It is nothing but the complete transfer of bonded pair of electrons, that is a pair of pi electrons of multiple bond to one of the bonded atom under the influence of attacking agents is called electromeric effect or E effect. That is, if we take the unsaturated compound such as double or triple bonded compounds, alkenes or alkynes, so what will happen? The bonded pair of electrons, that is the pi electrons of the pi bond of multiple bond, the electrons are electrons from this pi bond, they get transferred to one of the bonded atom, which will be under the influence of one attacking reagent. So if you take the example of the carbonyl group plus under the influence of the cyano group, this cyano group is electron withdrawing group. So what will happen, there is a pi bond between the carbon and oxygen. As a result of this electron withdrawing group, or which is more electronegative group, so what will happen, there is a difference in the polarity, that is the pi electrons of the pi bond, they are transferred to oxygen, because oxygen is also electronegative than the carbon. So as a result of which the polarity rises, oxygen gets a small negative charge and carbon gets a small positive charge. This is mainly due to the polarity of the bond between the carbon and oxygen, which was under the influence of this attacking reagent, so which transferred to the electropositive carbon, or the positively charged carbon atom, which is electron deficient. So this is how we can see this is nothing but the transfer of bonded pair of electron of a multiple bond to one of the bonded atom under the influence of attacking reagent is called by the name electromeric effect or E effect. And it is a temporary effect, because as long as the attacking reagent is there, this effect is permanent. If attacking reagent is removed, then the molecule restores its original position. So it is a temporary effect. So this is the polarity, which is mainly due to the difference in the electronegativity of carbon and oxygen. Carbon gets a positive charge and oxygen gets a negative charge when attacking reagent is added. So if the attacking agent is removed, so there is a retain of the polarity between the carbon, the removal of polarity between carbon and oxygen, and this effect also may be of two types, plus E effect and minus E effect. The effect, this effect is called plus E effect if the electrons of the pi bond are transferred to that atom to which the reagent gets finally attached, then it is called as plus E effect. Say for example, if the hydrogen is added to the double bonded carbon atom in case of alkenes, what will happen, there is as a result of the attack of the hydrogen to one carbon atom which is bonded to the double bond for another carbon atom, the carbon gets attached to the hydrogen gets attached to the carbon, and as a result the positive charge is created on the carbon, another double bonded carbon. See, this is the hydrogen. This hydrogen attacks one of the double bonded carbon atom. So as a result, what will happen? The electrons of the pi bond get transferred to this carbon due to the attack of hydrogen atom. So this creates a positive charge on other double bonded carbon atom. So as a result, we are going to call this as the plus E effect. The reagent H gets permanently attached to this carbon, wherein the pi electrons are transferred to this carbon, to which the hydrogen is permanently or finally attached. So if the electrons of the pi bond are transferred to that atom other than the one to which the reagent is finally attached, then it is called as minus E effect. So say for example, if same example, if a carbonyl group is attacked by the cyano group, so what will happen? Due to the attack of this cyano group to the double bonded carbon, the electrons of the pi bond, they get transferred to the oxygen instead of carbon, and as a result oxygen gets a negative charge, so it is called by the name minus E effect. And next is a very important theory, which is hyperconjugation theory and resonance theory, that I will discuss in the next session. Thank you.